Hello students, in today's class we shall discuss about state variables. In previous class we have discussed about the macroscopic property which are associated with the thermodynamic system. So in this video we shall discuss about the state variables, state function, path functions. So here state variables, these are the measurable properties or macroscopic properties of a system which completely define the state of a system. It is also known as thermodynamic variables. Examples are pressure, volume, temperature and amount of the substance. So these are called state variables which define the state of a system completely. State variables are directly measurable from experiments and are interrelated by the equation of state, and that equation of state is PV is equal to nRT. Here P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant and T is the absolute temperature. As the state variables are interrelated, it is not necessary to define every variable. We need to specify the value of only independent variables because the value of the dependent variables can be calculated with the help of this state equation, that is PV is equal to nRT. Because if you don't know the value of P and we know the value of V, N, R and T, then we can easily find out the value of P just from this equation, that is PV is equal to nRT. So we are in need of only independent variables and other variables can be easily calculated with the help of state equation. Next thing is state function. State function, it is a physical quantity when its value depends only upon the initial and final state. So in the state function, the value of it will depend only on the initial and final state of the system. And in case of path system, you will see that it is a physical quantity in which change in the values depends upon the path by which the change occurs. So this is path function. So examples we have for the state function: internal energy, pressure, temperature, volume, enthalpy and entropy. These are the examples of state function in which the state function, its value depends only upon the initial and final state irrespective of their path. But in case of path function, the like heat and work, their value depends upon the path by which the change occurs, and it is independent on the initial and final state of the system. It depends only on the path. We have the example heat and work. These are the path function, and state function example internal energy, pressure, temperature, volume, enthalpy and entropy. These are state functions example. Next, moving to the thermodynamics process. Thermodynamics process, it is a method of operation with the help of which a system changes from one state to another. These may be of given type. Isothermal process. Isothermal process means the process in which throughout the process the temperature of the system will remain constant, or you can say change in temperature that will be zero. If initial temperature is T and final temperature is T2, then because process is isothermal, iso means same, thermal means temperature. So in both the cases you will see from the initial state and from the final state that the temperature will remain constant, means T1 is equal to T2, and if we find out the change in the temperature, that is delta T, which is final temperature minus initial temperature, that is T2 minus T1, it will be 0 because the value of T2 and T1 is same. That's why the change in temperature we will get here 0. So here you will see that in case of isothermal process, we have the equation PV is equal to nRT, and from the Boyle's law we know that pressure is inversely proportional to volume at constant temperature. Here we have considered ideal gas in a cylinder. here temperature of water bath is constant. If we plot a graph of pressure and volume, here one point indicates the initial state and second point, this represent the final state, means from moving from initial state to final state. Here you will see that the pressure is going to decrease, and accordingly the volume is going to increase, right? From this expression, P is inversely proportional to V. As the pressure increases, volume decreases. And if we do compare it with the time and temperature, you will see that on increasing time, right, there is no change in the temperature. The value of initial state temperature and the final state temperature, that will remain same no matters how you will increase or decrease the time, because the process is isothermal. Throughout the process the temperature will remain constant. That's why the initial state and final state will have the same temperature. Another thermodynamic process is adiabatic process. In this adiabatic process, it is a process during which no exchange of heat between system and surrounding. Means heat is not going to be changed, or you can say that delta Q, change in heat, that will be 0, because the initial state and the final state heat, that will remain same, that is Q1 is equal to Q2, and delta Q, that will become equal to Q2 minus Q1, that will be 0. So no exchange of heat between system and surrounding in case of adiabatic process. Here in adiabatic process you will see that during expansion, what will happen, internal energy U is the internal energy of the system, that will decrease and temperature will decrease, and during the compression internal energy will increase and accordingly temperature will increase. So from here one can relate that the internal energy is associated with the temperature. More will be the temperature, more will be internal energy. So U is internal energy and T is the temperature. Next process is isochoric process. In the isochoric process, iso means same, choric means volume. So that process in which throughout the system, or you can say the volume of the system, that will remain constant. So here one can say that change in volume, that is del V, V2 minus V1, that will be 0, because here volume is kept constant. That process is called isochoric process. Here you can see the volume of this container is fixed, having ideal gas, and if we supply the heat and if we have kept the temperature constant, then you will see that the pressure volume graph, the volume will remain constant from the initial state to final state. It is independent of the pressure. Pressure is going to increase, but volume is fixed here. So that type of process is called isochoric process. And here you will see that PV is equal to nRT. P is directly proportional to T when the volume is constant. So this is another relationship in which the volume is kept constant. So the process in which volume of the system will kept constant, that is called isochoric process. Next, moving with the isobaric process. Iso means same, baric means pressure. So it is carried out under condition of constant pressure, or you can say delta P, change in pressure, that will be 0. Here we have the example that liquid is heated with the help of heating coil. You can see here, this is the heating coil and this is liquid water. And if we look over the graph of temperature and time, you will see a curved line. And here as the time is going to increase, and if you are going to heat this water with the help of heating coil, the temperature will keep on rising. Next process is cyclic process. In the cyclic process, when the system follows a cyclic path for undergoing a series of changes in its state, and finally the system comes back to its initial state, and the method of operation is called cyclic process. In this cyclic process, you will see in the form of triangle A, B, C, starting point is A, then it will move to B, and then move to B, from B to C, then from C to A. Means after the process, the system will achieve its original state, that is, it is going to come back at point A. So that type of system is called cyclic process. Likewise here, pressure, volume, we have the plot. If starting point is A, then it will move to B, then B to C, then C to D, and finally it will come back to A, from D to A. So this is called a cyclic process. So we have discussed about the cyclic process, isobaric process, isothermal process, isochoric process, and if we compare them, you will see that the actual point is, in thermodynamic process we have isothermal, change in temperature will be 0, that process is isothermal, and in isochoric change in volume will be 0, and in isobaric delta P means change in pressure will be 0, and in adiabatic change in heat will be 0. So in this video we have discussed about the thermodynamic process, state variables, path function and state function. I hope you will find this video useful. Have a great day. Thank you so much.